All right, so for those folks who didn't have a chance to read the abstract, what we're really talking about here is assurance, right? So a lot of talks that we're probably hearing this week and a lot of research that you've done already. If you're looking to soon or at least start researching your SDN and NFV initiatives, we don't see a lot of folks out there talking about assurance. How are you going to monitor and manage these networks, right? Your networks are only as good as the management and monitoring tools you have in place. And we're going to talk about the lack of assurance out there today, what CA has on deck that can provide you guys with the assurance you need to move to those next generation networks and what it takes. Real quick, we'll talk about why CA is even in this space. For those folks who know CA, we have a long history of being in the physical network world. Very many customers out there happily managing and monitoring their physical network space very successfully. Why are we moving into this area as well? The challenges around SDN and NFV deployments, the management needs. We'll give you a quick one-slide intro into the product that we released at the end of last year called Virtual Network Assurance, and talk about some of the use cases and technical requirements that are satisfying a lot of the CSPs out there today that we've talked to. So why is CA even in this space? I spoke to SDX Central today. They agreed with the quote we have here from one of our large cable provider companies out there. There are a lot of equipment vendors in this space today, driving the innovation around SDN and NFV and next generation networks, but there's not a lot of software vendors out there today. I was at an Intel Cloud Summit event a couple weeks ago in San Francisco, and my product manager sat on a panel and he said, in order to make customers successful with SDN and NFV, all the ecosystem vendors have to get along. We have to play nice. It's the only way we're going to make customer initiatives on SDN and NFV successful, and that's why we're in this space as well. And our customers are asking us to move into this space. They have success with the physical network world and managing and monitoring fault and performance management. They asked us to move into this space to extend their existing investments to the next generation network. So the likes of some of the big CSPs you see here on the slide, I'm not going to go into the names, but they came to us and asked us to help them innovate their next generation networks with their existing CA infrastructure management solution. So we're proud to be part of that development and innovation. Like I mentioned, we have 20 plus years experience in the physical network world, satisfying some of the largest telcos and large enterprises out there today with their physical network monitoring needs. It just makes sense to help them move into the next generation network world when it comes to assurance. From the many products we have on our docket and the 20 plus years experience we have in network management, and the fact that CA is such a large software company, we are happy to innovate in the security side of the house. The top 20 out of 25 Fortune 500 companies secure their networks with CA. There's no reason CA shouldn't be helping to secure your networks in SDN and NFV. So we have that expertise and are happy to help our customers innovate that way. But there are problems, right? There are gaps in today's infrastructure management solutions. Enterprise Management Associates, EMA, recently did a study. I don't know if anybody saw it out there. The impact of SDN on network management. And what they found is that over 2/3 of the surveyed CSPs and enterprises revealed that their infrastructure management solutions today were not ready to monitor SDN and NFV. The other third that said they were ready, I kind of wonder if they are really ready or they just answered the question, yeah, we're ready for it, but time will tell. So help is needed out there to get our customers and the folks in the room today deploying SDN and NFV from a management and monitoring standpoint. Let's talk about those gaps, okay? The gaps in infrastructure management today to be successful with SDN and NFV. Well, we all know the old network, right? We know it's physical, appliance-based. When I was running data centers, we all know it could take weeks maybe to get a router up and running and the T1 tested and remote offices turned on and rack to stack the equipment. Nothing is at the speed of what SDN demands today. When it came to provisioning or monitoring our physical network infrastructure, it was involving a lot of manual processes, long provisioning times, over bandwidth subscriptions, throwing more bandwidth at a problem just for an insurance policy. And then what SDN and NFV brings to the table is a velocity and a complexity that really has never been seen before when it comes to network operations in the physical network world. My colleague here, Brian, who will be speaking at the latter half of the deck, uses a great line, and I use it all the time. You know, SDN and NFV means with the right click of a mouse, we could, you know, mistakenly deploy 1,000 virtual firewalls by mistake. Maybe we meant, you know, right click and deploy 10. But that right click of a mouse could eat up most of the data center resources you have in your environment today. How do you, at the speed of what SDN demands, react to that? These are some of just one complexity challenge we have with network operations today to satisfy the SDN NFV challenges. And you know, diving deeper into these challenges, you know, complex layering. So the SDN NFV network stack. If you, I'll show you a slide, but if you can visualize it, you can imagine it's a lot more complex than our layer 7 network stack today. How do you map those underlay and overlay relationships? What are the physical hosts? You know, what are the virtual or the NFVs and the VNFs that are being hosted on physical nodes? What's the dependencies and relationships? If I drop or lose a physical server, what are the affecting VNFs on that? You know, and obviously, what's the end user experience and how that's affected, or the tenant that's hosting those? You know, performance in today's physical network world is done on the physical layer, right? And now performance inside of SDN and NFV is going to be done inside of software. There's going to be problems. You know, performance was always managed and done through the physical layer, and that's not how we're going to be seeing SDN and NFV evolve. There are going to be problems. And like we talked about, the velocity, the fact that things can get spun up and spun down in the SDN NFV world so quickly. Network operations is not able to keep up with that velocity and complexity today. They have to have the ability to have a management tool in place to detect those changes so quickly and let folks know what's going on at the speed of what SDN demand. Service chains. We all know service chains are probably one of the biggest drivers of SDN and NFV today. To be able to chain together these VNFs for a customer service. Being able to have customers build service chains themselves. What are the building blocks that make up service chains? Like we talked about, the physical layer and the vSwitch, and any one of those things has a vulnerability, the service chain will be affected. It needs to be tracked. Automation. So I'm not saying that CA has a self-healing product today. Nobody does. But what our customers like to hear is that our vision and our roadmap for our management and monitoring tool has self-healing involved in it. So the idea of injecting accurate performance data from a CA tool back into the SDN ecosystem, so the orchestrator can auto-provision another virtual CPU or another gig of RAM because we hit that 80% threshold, and not wait for a network operator to make a manual provisioning task in order to resolve that bottleneck. That's where we see self-healing happening, and that's only going to happen with accurate performance data being injected back into the SDN ecosystem. And then, you know, being able to use and not rip and replace management and monitoring tools out there today for SDN and NFV is really important. Our customers want to be able to use their existing assets today that manage the physical network world so well and just extend that visibility into SDN and NFV, and we want to help them get there. So we talked about the complex and highly dynamic network stack. This is how CA visualizes it, right? It should look pretty similar to what we know a network stack to be today. If you can't read it, physical layer on the bottom, some hypervisors, virtual routers and switches, tunneling, VMs, the always important and revenue generating service chain, and then our controllers and orchestrators on top. Now, this may look kind of simple now, but just imagine this stack in Verizon or in AT&T or some of the largest telcos out there. We're going to see tens of thousands of devices on every single layer, talking and you know, dynamically changing and moving. And how do we keep up with these and track these type of changing environments? Customers need to understand they need to identify weak performance spots in this stack, right? How do I stay on top of what could be crumbling inside of this stack? How do I relate stack performance to the health of the service chain? Again, the most important part of the stack is the service chain. A lot of our customers are telling us the performance of the entire stack is important to the service chain layer. Keeping track of the relationships, the physical to the virtual, the underlay to the overlay relationships and dependencies. And then how do I dissect the stack and rebuild it, maybe show it in a topology format, a visual format, is important to our network operations teams. Our CA Spectrum solution is really, really good at being able to map topologies and easily visualize what today's telco networks look like. Performance weaknesses, and relate that to the physical network, so virtual to physical relationships. And then really, from a utilization and capacity planning point of view, am I still over-provisioned in my SDN environment? Am I still throwing bandwidth and spending a lot of money in this environment as an insurance policy? There's no need to do that anymore. You know, one of the use cases at SDN and NFV, and everyone knows, is CapEx savings. There's no reason why a management and monitoring tool can't help you understand how well or not how well you're utilizing these virtual investments now. It's important to still continually saving money. So if we continue to look at this visualization of the SDN and NFV ecosystem and stack, what do these operational challenges look like to the network operations teams when it comes to keeping up with the complexity, keeping up with how dynamic this stack can be? Well, it boils down to typical network operation challenges, right? But in a whole new world of complexity. How do I begin to visualize the physical to virtual network relationships into this stack and understand what's dependent on what in case we lose something? How do I track performance within this stack? The service chain breeds complexity. So complexity breeds, multiple layers breeds complexity. Complexity can breed outages. So understanding where performance bottlenecks can be and how they affect the service chain. And then, of course, all this comes down to increased mean time to repair. If I don't know what's going on, if I'm not identifying performance issues and weak performance spots in this stack, my mean time to repair is really going to be increased. So really running out of time here. So, all right, so CA's solution to the SDN and NFV challenges is CA Virtual Network Assurance. It is a flexible software gateway that really sits in front of existing infrastructure management tools today that do something so well in the physical network world, but enables them to talk to the virtual network world. So it's able to talk via the APIs and the other operating and communication protocols that today's infrastructure management solutions can't talk today. SNMP is not going to be the way we're going to collect this performance data. So today's infrastructure management solutions subscribe to what virtual network assurance from CA is collecting at the speed SDN demands, at the velocity SDN demands, throughout every single layer of the stack, and it feeds that information back into the same UIs, the same dashboards, the same GUIs of today's infrastructure management solutions today. So it's the same look and feel for our customers, the same dashboards they know and love. They're just getting SDN and NFV performance data they were never able to get to before. And what does that bring? So, in a nutshell, in this very quick presentation, when we're able to use a monitoring and management solution that is at the speed of what SDN demands, we're able to isolate performance outages. We're able to map the dependencies between these layers, really get through all the operational challenges we talked about before. So if we can identify maybe one of those virtual machines is about to consume most of its CPUs allocated to it, a network operations team has that information in front of them, can react to that information, and then really take the management complexity out of this stack and really focus on the end user experience. When they have the information in front of them, they can make these logical decisions to improve the end user experience in this very complex environment. I'm going to hand it over to Brian. He's got about 10 minutes. He's going to take us through the rest of the deck and some use cases that apply to this new technology.
Great, thanks, Jeremy. So what we're looking at here is a service chain view. Okay, so we can see at the bottom layer, we're looking at the compute node. Okay, above that, we're looking at a virtual switch, then the virtual machine, and at the very top, the VNFs. And when Jeremy was describing the gateway, what's important to understand is the compute node might come from vendor A. I might be using an Open vSwitch. I might be using Contrail for my controller. So that's 3 different vendors that I need to correlate and understand when there's a problem inside the environment. And that's what the gateway tool does. So I can get a nice visualization because we're taking all that information in and doing that technology mapping on the back end. So here's a little deeper architecture. The gateway itself is broken into two logical entities, one that we call the open collector, and that's how we talk to each vendor's specific API or the technology that they're exposing for us to get fault and performance metrics. So in an OpenStack example, we would authenticate with Keystone, we would talk to Ceilometer, we would get those performance metrics, and then we would take them back into what we call the broker. And that's where we normalize all this data and start doing that mapping. Okay, so how does this neutron network connect to this other piece of the infrastructure, things like that. We keep an inventory, so when we have someone subscribe to the system, we can figure out, okay, this is the first time that this entity has subscribed to the virtual network assurance. We're going to push them all of our inventory information and then start pushing them fault and performance information. What's really nice about this product is at the bottom you'll see something called Extensible plugin. Plugin is just our terminology for how do we speak to technology X. So it could be a VNF, it could be an orchestrator, it could be a controller. And the way we've designed this is that you can install a plugin and leave the application server itself running. So as you start bringing in new equipment, or if it goes through a version upgrade, you simply install that plugin in place and everything else keeps humming along. So how does this fit into the Etsy model? So very important as well. We want to make sure that, like Jeremy was saying, that we're playing well with others, right? So this is where we lie out. So virtual assurance, we'll talk to the NFVO, the VNFM, the VIM for whatever vendor has been selected inside the environment. We'll use their native APIs to gather that information. But then we'll also reach out on the back end possibly to the VNFs themselves. So for example, one of our customers has checkpoint firewalls. Those VNFs will run SNMP. So we can enrich the data that we get through the EMS and the orchestrator through SNMP data. Now, is that always going to be able to be the case? No. But when it is possible, we'll use multiple avenues to get data so that we're presenting back to you the most information possible. All right, so a couple of the use cases that when we were developing the product we wanted to really key in on were these three. So virtual CPE, software-defined data center, and SD-WAN. When we had gone out and canvassed our customers, these were the three things that they said, hey, can you start with this? Everything else is going to be a nice add-on after that. So the way we're approaching developing this product, it's done with an agile development methodology, but we actually sit in a customer's environment that has one of these use cases and say, what equipment are you using? How are you approaching this problem? And then we develop around that. And we found that that is giving us real-world information and use cases. So we're not developing in a lab and then coming to market and having it miss the mark. So part of the reason why we're here is to find new partnership opportunities with customers as well as equipment vendors to make sure that we're including everyone when we can. All right, so I'm going to walk you through a very quick use case here that highlights just a very small portion of the tool. But it's basically we've onboarded a new tenant and we want to make sure, we want to validate their service chain, right? So part of the operational workflow is we onboard the tenant and then we validate their service chain. So inside the product comes with a bunch of dashboards out of the box, again, because we've worked through these use cases already with actual live customers. So we can come down and say, hey, I want to look at all of the tenants that I have defined inside my environment. And again, this is discovered through talking to the orchestrators and the controllers and all of the infrastructure, right? So this isn't something that someone's keying in. It's being discovered. And when I pick one of my tenants, I'm able to see, and it might be hard to read in the room, but at the very top, it's a list of all the virtual machines inside the environment. Then I have a list of all the service chains, and then all the VNFs. So with 3 clicks, I've found the tenant, and I've said, show me everything inside their environment that's been spun up as part of this onboarding process. So this is immediate validation that they have the number of service chains that they've required, the VNFs are there, and virtual machine inventory is there as well. I can come in and say, show me what the service chain looks like. So this is the picture we had just seen a little while ago. So I can see, okay, well, I have 3 VNFs inside this service chain. That's exactly what they ordered. The VNFs are doing the functions that they ordered. But you know what? I want to get some performance information on this. So what I can do is, from that view, each of those items is a hot zone, basically. And when I double-click on them, I'll get more information. So if I double-click on a virtual machine inside that service chain, I'll go out, and if it's, again, the OpenStack example, I'll go out and get kilometer data on that virtual machine and present it to you. I can then look at the compute node. So the compute node, it's physical, so we would have to look at it through SNMP or maybe a LOM card or something like that. But again, we know what protocol or how to query it to get that information and present it back. And then the vSwitch. So an open vSwitch, for example, we've created an OVSDB client. So we go in there, we can see all of the virtual interfaces, we can see the bandwidth utilization, errors, discards. We can see the CPU and memory utilization of that vSwitch, just the processes that make up that vSwitch. And that allows me to do things like quick visual correlation. As my CPU utilization goes up, are my discards going up? Okay, do I need to start allocating more bandwidth because, hey, if this is on COTS hardware, it's not optimized, right? So there's probably a very direct correlation there. And these are the kinds of challenges that we've tried to solve with the tool. And then I think Jeremy's going to wrap it up here.
Yeah. So again, we're happy to be leading the innovation in SDN NFV assurance in the space right now. We have vetted this with many analysts, some of them even here this week. Our friend PJ at ACG Research is happy to say that we're taking an important step forward and helping to accomplish the efficiency and agility goals so central to SDN NFV, and EMA agrees that we've definitely delivered a technology that enables SDN NFV management and monitoring. Brian showed you some of the SDN NFV health dashboards. We talked to you about how important it is to help optimize the service chain and taking different metrics like Brian mentioned, whether it was SNMP, Open API calls, and showing them integrated, analyzed, and presented to you in one dashboard. Honestly, you're going to see these I want to see type examples. We get these straight from our customers. This is what they wanted to see from their infrastructure management solutions and what the virtual network assurance would enable them to do. They wanted to see self-service inventories and the life cycle trends. They wanted to see of those inventories how much resources are being utilized. I want to do thresholding and find out where the vulnerable layers are in that entire stack. And what are the building blocks that make up the service chain and where are they vulnerable as well? That's from a performance management point of view. From a fault management and isolation point of view, they want to see the underlay and the overlay mapped and the relationships and dependencies between the physical and the virtual world. Where's data taking, or what's the path that data is taking across the service chain? Correlating everything in real time or near real time, and then isolating, finding a fault and where it's affected in that critical service chain and overlay layers. So I am out of time. If anyone in the room is happy to have more discussions on this, a deeper dive, a deeper demo, come visit us downstairs at the CA Technology booth. I'm very happy that everyone attended today. If you have any questions, we can have further discussions downstairs. But thank you for attending.